everyone, so we're going to continue our lesson on finding the GCF, or the greatest common factor. So we're factoring here, okay? So let's go ahead and look at our example here. So we have three different terms. We have 14a plus 21a squared plus 21a cubed. So when we are factoring, we've got to think of division. What number can go in to all three of these terms, okay? So I'm going to go ahead and set up my ladder. So let's go ahead and look at our coefficients. So for this term, we have 14, we have 21, and we have 21. What number can be what number can be divided by 14, 21, and 21? Like, what number is divisible by all three of them? So we know that we couldn't use 14 because 14 doesn't go into 21, but what number can go into 14, 21, and 21? So let's go ahead and I'm going to tell you it's 7. So I'm going to pull out a 7. Okay, we know 14 divided by 7 would be 2. And then we'll go ahead and pull down our A. Plus 21 divided by 7 is 3. And we haven't touched this one. We're going to say A squared. We're pulling these down because we haven't touched them yet. Plus 21 divided by 7 is also plus 3, and then we're going to pull this down because we haven't touched our a's yet. A cubed. Now, when looking at these numbers, I want to determine, is there anything else that these three terms have in common? Yes. I see that nothing, looking at our coefficients, nothing can be divisible by 2, 3, and 3, but I do see that they all have an A, and an A. So what I'm going to do is I'm going to continue drawing my ladder. So since they all three have an A, and an A, we're going to go ahead and pull out our A. And let's see which one has the smallest exponent. And I see that this one would be that imaginary 1, 2, and 3. So we know this is the 1. So A to the first. That's our imaginary 1. So we're going to take out our smallest one. So if we're pulling it out, we're going to say we don't have to pull anything out of our coefficients. So we're going to say 2A divided by A. They cancel out. So we're not even going to write them. Okay? Plus, we're going to pull down our coefficient, 3, because we've already done the work here, so we don't need to do anything to our coefficient. A squared divided by A to the first. And it's division, so we're going to look at our exponent, and we know we subtract when we divide. So 2 minus 1. So we know that's going to be A to the 2 minus 1. It's going to be A to the first, or just A. And then we're going to look at our third term. Plus, we're not doing anything with this one because we'd already done it up here. 3. So A to the third, looking at this exponent, divided by A to the first. So we're going to subtract our exponent. So A to the third divided by A to the first. So 3 minus 1 is 2. So it's going to be A squared. And if we're looking back at this, we know that there is nothing similar that we can take out. Nothing that they have in common. So we are done. So let's go ahead and write our final answer. So I see that these two sit outside of the ladder. So I'm going to make sure I write that. Okay? Anytime anything sits outside of the ladder, we're going to multiply them and put them together. So 7 times A is going to be 7A. And then we're going to write our parentheses times whatever's right here. 2 plus 3A plus 3A squared. And that is your answer for this one. So let's go ahead and look at another example. Okay? go ahead and write it here. So we have 10n to the third minus 9n squared plus n. Okay, so we need to find our GCF. So let's go ahead and draw our ladder. So let's look at our coefficients. We have 10, 9, negative 9, and we have our imaginary 1 here. Does any number divide by 10 and negative 9 and 1? No. There is no number that is divisible by all three of these. So we're not going to worry about pulling a number out. Now, let's see what else they have in common. There's an n here, an n here, and an n here. So they all three have n's. So we're going to go ahead and pull out our n. Let's look at the exponents. Which one has the smallest exponent? And it would be this one right here because it's got that, imaginary 1. So we're just going to keep it as that n right here. So let's go ahead and start dividing. So we're not doing anything to our coefficient, so let's go ahead and bring that down, 10. So n cubed divided by n, and if we have to put in our imaginary 1, we can, divided by n to the first, we know we're going to have an n. And when we're dividing, remember this ladder, symbolizes some kind of division here. 3 minus 1, because we subtract when we're dividing with exponents, 3 minus 1 is 2. Because essentially there are 3 n's. So like this would look like n times n times n. So if we were dividing all of that by this, and let me write it off to the side, so it would be n times n times n divided by this n, we would end up canceling it out, so we would have 2 n's. And that's where we get this n squared. Minus 9, because we're not doing anything with our coefficients. N squared divided by n to the first, and we're looking at our exponents, we are subtracting, so 2 minus 1 is going to be 1, so we're going to have n, and then, to the first, if we've got to put in our imaginary 1, plus n divided by n. And again, n divided by n, anything divided by itself, it cancels out to equal 1, so it would be 1. And let's go ahead and write our final answer because there's nothing else that any of these three terms have in common. So I'm going to take this n that sits out here and write n times this whole piece right here. 10n squared minus 9n plus 1. And that is your final answer for this one. Let's go ahead and look at one last example. I'm going to scoot my camera down. So we're going to have negative 8x to the 7th plus 24x to the 6th y plus 12x to the 5th z. Okay, let's go with this one. So I know I'm going to be looking for my GCF, so let's go ahead and draw our ladder. So I'm looking at the coefficients first, and the first thing I notice is that there is a negative right here. Our first term has a negative, and negatives are, just pull the negative out. So we're going to take this negative and we're going to pull it out right here, because when we end up dividing, we're going to end up changing the signs of these so we don't have a negative in the front. Okay? So let's go ahead and find the GCF. So let's look at our coefficients. We have 8, 24, and 12. Okay? So what number can go into 8, 24, and 12? Now 2 is a number that could easily divide into 8, 24, and 12, but I'm thinking of a number even bigger. 4. Let's go ahead and go with 4. Okay? So we know 8 divided by 4 is 2, 24 divided by 4 is 6, and 12 divided by 4 is 3. So we know that's going to work. What else do we see in here that they have in common? Let's keep looking at these. So I see that there's an x here, an x here, and an x here. So they all have an x in common, so let's go ahead and write x, and let's look at our exponents and see what our smallest exponent is. So we've got a 7 here, a 6 here, and a 5 here. So the smallest of these exponents is a 5, okay? X to the 5th. So we can safely pull that one out. Now let's keep looking at the other pieces in here. So we see that this one has a y. Does any of the other ones have a y? No, so we can't pull that out. And let's look at this one. This one has a z. Do any of the other ones have a z? No, they don't. So we can't pull them out. Like they're in that term and that one's in that term. This y sticks with this one and this z sticks with this one. So let's go ahead and using this piece here, we're going to divide out each term, okay? So let's take this one term at a time. So -8 divided by -4 is going to be +2. X to the 7th divided by x to the 5th, we're going to have our x, but we know when we divide, we're going to be subtracting our exponents. So 7 minus 5 is 2. So we're going to have a squared here. Now, we're moving on to the next term right here, this piece right here. So 24 divided by -4 is going to be a -6, okay? Because when you're dividing a positive by a negative, it's going to stay negative, okay? So now let's look at our x. So x to the 6th divided by x to the 5th, we know there's an x there. So when we're dealing with exponents, we subtract when we're dividing. So 6 minus 5 is 1. So we could put our imaginary 1 in, but we just know it's an x, so x to the 1st. I'm not going to write it for this example. So we can start to look at these without the imaginary exponents as well. Now we have this y. We're not pulling it out, so we're leaving it. Y. Okay? Now let's look at our next term here. 12 divided by -4 is -3. Okay? And when you have a positive divided by a negative, so we change that sign, -3. X to the 5th divided by x to the 5th, that cancels out. So that's essentially saying x to the 5th divided by x to the 5th. Anything divided by itself equals 1. So we're going to say, we're not going to write anything. So that cancels it out, right? So we're going to bring down our z right here, though. So that z does come down because we didn't take it out. We didn't take it out, so we've got to keep it. Now, I'm looking here, and there is nothing else that they all have in common. These two may have x's, but this one does not have an x, so we can't pull anything else out, okay? That's just an example. So now I'm going to write my answer, -4x to the 5th times, and we're going to write everything here in these parentheses, 2x squared minus 6xy minus 3z. And that here is your final answer.